Hi, this is John Roberts from Pivotal. This is a presentation I gave at the Greenplum Summit in March of 2019. The presentation will cover running Greenplum running in the cloud marketplaces. In particular, Google GCP, Amazon AWS, and Microsoft Azure. When you're running in the cloud, you have some common goals, and some of these goals are actually the exact same ones you have for running on-premise. Obviously, you're using Greenplum because it's fast. You can scale out and have lots of nodes and run real fast. So in the cloud, you want to have that same benefit as you're running on-premise. When you're running in the cloud, there's also some features that are cloud only, and you want to be able to leverage those cloud-specific features such as snapshots and auto healing. So we'll be discussing that in this presentation. And then you also want to have same experience across clouds. If you go from Google to Amazon, you don't want to have this huge learning curve associated with just deploying your cluster in a different cloud. And so we've done a lot of work making sure that the deployment is the same across all clouds. And lastly, but not least, you want to make sure that it's secure. Just like you have an on-premise installation, which you're deploying in the cloud, you want to make sure it's secure as well. So fast, let's talk about speed, right? So companies are using Greenplum because of speed. You use it for business intelligence, data warehousing, big data, analytics, predictive modeling, those type of things, data science. And you want to have that same experience in the cloud too. So you never would want to just run it in the cloud and have a much worse experience than you would have on premise. So we've done a lot of tuning in the cloud marketplaces. So what is tuned? So first off, we've tuned the virtual machine itself. So like the instance type that the different marketplaces have available. We've tuned the operating system. So we're running CentOS, and we've done a lot of tuning and configuration of the operating system itself. There's also the disk, memory, and network tuning we've done. In disk in particular, there's been a lot of tuning associated with that because of the different limitations and speed limits that different cloud vendors put on the disk in a virtual machine in their clouds. And then there's also the marketplace template itself. So there's a template that's used to deploy all the different resources in the different clouds, and so we've done a lot of tuning to make sure that those are done in optimal fashion. So how you measure this tuning, right? So GP checkperf is one utility we've been around since probably the early days of Greenplum. It checks network and disk performance. We use that. It's the same tool you can use on-premise. TPC-DS benchmark, which I'll talk about here in a minute. And then some cloud vendor specs. So the cloud vendors provide specifications for a lot of different configuration items, whether disk, memory, network, by instance type. So first, TPC-DS. So TPC is the Transaction Processing Performance Council. And the DS is the decision support benchmark, which has become the de facto standard for big data warehousing. There's a lot of different vendors use this. The councils or members of the TPC, including Pivotal and some competitors of ours, like Cloudera, IBM, and partners, VMware, Dell, and so forth. So many companies are part of this council. So the DS benchmark itself has 24 tables and a star schema. It has 99 queries. It has what we've settled on is using 3 terabytes of data for the test, and then we run 1 and 5 users. So one user would run all 99 queries, and then subsequently 5 concurrent users run the queries in a random order. So it runs through all of those queries to simulate a high concurrency. At the end of that, we come up with a score to measure the performance. A score is based on the duration or how long it takes to execute all those steps of loading the data, running the queries, 1 and 5 users. So these scores, the numbers are going to be a function of the duration and the hardware, right? So because we are an MPP database, the more hardware you throw at it, the faster it will be and the higher the score. So to kind of normalize this for you, we've used the number of cores deployed for the segments to be able to baseline do an apples-to-apples comparison. And the larger the number, the faster the cluster, right? So you can see that 256 cores, the Azure and AWS, the H8 and R48X large, are 18 and 30 respectively, and then a hardware vendor. So there's some hardware installations here with in the red, and then right here an appliance. So this appliance is an on-premise appliance using 384 cores. To compare that to an Amazon R5 12X large, it's significantly faster than that on-premise installation. And you can see there's others down here, the GCP with high mem and standard memory, as well as SSD and HDD options. So the performance are about the same across all the GCP instance types, and that's because of how they throttle or put speed limits on their virtual machines, but it's been optimized as best as possible. So we can definitely run fast in the cloud just like we can on premise, and we've seen that with using the TPC-DS benchmark. To normalize this, so you can see a better comparison of score divided by cores, so how many cores does basically take to get that score, right? And then multiply by 100 to get it to make it easier to look at. You can see that the Amazon R5 12X large is kind of the best bang for the buck. That's what's running a full rack, like a 16 node cluster, which is running 768. I'm sorry, it's running 384 cores. But you can see that it's pretty much the same across all of them. There's some that are a little slower than others, but it's we are definitely fast in the cloud. So now goal number 2. So how can I leverage the cloud? What can I, by using the features that are available by the different cloud vendors, right? So on-demand provisioning, node replacement, disk snapshots, upgrades, optional installations, and some, it's on the internet. So let's take advantage of some of the web-based features. So on-demand provisioning. So deployments take less than an hour to complete, and that's a production scale cluster that can have those numbers we just saw in TPC-DS in less than an hour. This removes lots of barriers to evaluate and buy Greenplum, because usually you have to provision space on the floor space and for heating and cooling. Cooling and power for an appliance or a hardware solution. To start evaluating the product. This empowers business units. They can go and start looking at solving their analytic problems, data warehousing, big data problems rather quickly and easily by provisioning something in the cloud. How we've done that is using the native utilities built into the different cloud vendors. So in Azure, we're using resource group deployments, GCP is using Deployment Manager, and Amazon, we're using CloudFormation. The node replacement aspect of it. So we have self-healing, we call it in the cloud marketplaces. So if any node were to fail, it gets automatically replaced and recovered. So the identification and replacement of the node is done by the cloud vendor itself. And then when the new node comes back online, all the steps are executed automatically to recover the node completely. It doesn't matter if it's a master, standby, or segment host, it handles all of that for you. We've also used PG Bouncer as the connection pooler when you connect to the database. So what it does is it lets you, it pauses the rebalance command so in-flight queries don't get canceled. So it's completely seamless, and it makes administration very easy because it handles the healing process for you automatically. We're an on-premise installation. This may take days to get new hardware, rack it, cable it all up, and then do the administrative commands to move the data over to the new replacement node. This can be done in as little as 5 minutes. We also have a very good video on this on YouTube for an example showing how this works in Azure. So because we have self-healing, we don't necessarily need a standby master. So usually in our architecture, we recommend having a master node and a standby master node, where a standby is there in case the master node would fail. So that process is pretty lightweight. It doesn't, it's not really actively using CPU cycles, and it's just basically waiting idle until the administrator says, hey, make the standby act like the master now. So what we've done is we've pushed that standby master process to the first segment host. What that gives you is one less node in your cluster, so you're saving money on hardware and also Greenplum licensing. The self-healing is aware of this situation, this configuration, and so it will handle all of the recovery for you automatically. So if the master were to fail, it fails to the standby, and then it fails back to the master. If that first segment host fails, it will recover the segments, and then it will reinitialize the standby process for you automatically. So this is a big win for deploying to the cloud because you're saving money on infrastructure and also licensing. The snapshots. So in all three clouds now, we have the ability to take a backup using the native snapshot utilities within the clouds. So this is like a volume level snapshot. So what happens is when you take a backup using this new utility called gpsnap, it will stop the database, execute the cloud-specific commands necessary to take a snapshot of each volume. It labels the snapshot so it knows where to put those back in case you want to do recovery, and then it starts the database again. In GCP and Amazon, it takes about a minute for the largest cluster to take a snapshot. And so it's a little bit longer in Azure because of how Azure snapshots work, but it's taking advantage of the cloud infrastructure to take these snapshots. So you're talking about a full cluster backup in minutes. So terabytes of data, hundreds of terabytes of data can be done in minutes. We've also automatically configured weekly snapshots for you using gpcronsnap. And so that's just a configuration file. You can say how many copies of your backups you want to keep, and what days of the week to run, how often, so forth. And so, these are automatically configured to run keep 4 backups, and they run on every Sunday. Upgrades. So upgrades, because we have a pretty high velocity of new versions for Greenplum because of our agile software development, we found that customers will deploy a cluster, and then soon after will be a new version of Greenplum available. So GP release is a utility that will automatically upgrade the database to the latest release. It also includes optional installs. And so if you've chosen to install like Madlib, PostGIS, Command Center, so forth, it will also upgrade those components if needed as well. GP cron release executes weekly, and it checks for new versions. And when there is a new version available, what it will do is it'll update the message of the day. So when you SSH into the master node, when an administrator does that, he or she will see the message say, hey, there's a new version available. Run GP release to upgrade the new version. There's also a video of this on YouTube that shows you how it actually works. Optional installation. So when you deploy your cluster, you will see a list of optional installs. And these are the screen captures from various cloud vendors, so Amazon, Azure, and GCP. And what it does behind the cover is actually execute this GP optional command. So this can be done at deployment time or after the fact. You can, once you log in as administrator, it has GP admin to the master node, you can run GP optional, and that lets you install these optional installs after the fact, like Command Center, Madlib, so forth. We also have a web-based feature called Greenplum Browser, which is based on PHP pgadmin. It's web-based. It has a self-signed SSL certificate by default, but you can obviously change that to get a signed one. It's all open source, and it's a great, easy way to start using the database through a web interface to query the database. You can also use other utilities to connect to the database using normal database clients. But this gives you a very fast, out-of-the-box user experience to start using the database. The same experience across the clouds, right? So that's our goal number 3. You want to have a similar deployment, and you want to have the same tools, and you want the same software versions. So parameters when you create a deployment across the 3 different clouds, Azure, or AWS, Azure, and GCP, are going to ask for some of the same things, right? So you want to ask for the name of the cluster, and you see the stack name. Amazon has a stack instead of a deployment name. And then there's availability zone for where you want it deployed, or resource group plus location in Azure, and a zone in GCP. SSH key is like basically the key to get into the database or into the through SSH. And who can access, which is the CIDR, the location of who can access. And you can also change that after the fact, after your deployment. You can remove that, create a VPN connection to the cloud if you want, and use that instead. The subnet CIDR, so this is the IP address range within the new subnet that will be created in your private network for Greenplum. The instance type itself, so Amazon and Azure, we have combined instance type with storage because the storage has to be configured with the instance type because of how the performance is tied together of instance type and storage. GCP, the storage does not, the size of the disk doesn't, and the number of disks doesn't matter for performance. So that's why we have we've separated the instance type from storage. And then how many? So how many nodes do you want to actually deploy? So this is the Amazon user interface, and this is the CloudFormation user interface, and it has stack name instead of deployment name. But other than that, all these other parameters are pretty much the same. As you can see, they're just who can access, where you want it deployed, that subnet CIDR, and then the instance type and how many. One thing is unique to Amazon is how they manage SSH keys. They have you create a key pair, they call it, where they keep track of your public key, and they will put the public key on the new nodes for you. You have to keep track of your private key to access this node. Azure has very similar, or has the same parameters, right? But just different user interface here. You see it has a deployment name, the SSH key, the location, subnet, and resource group. And here you can see that the SSH key is actually, you have to keep track of the key pair yourself. You have to keep track of both the public and private key. And here is where you put in your public key, and you keep track of your private key. And then this is a second page to show the parameters, because it doesn't have it all on one page like it does in Amazon, but it has the instance type and the instance count. And you can see that when you pick the instance type in Azure, it also defines the storage as well. GCP is all on one page, and it's pretty straightforward. It has deployment name, zone, subnet, instance type, node count, storage, and location. And what's neat about GCP is how the keys are handled. So when you SSH in with their CLI, or if there's the web interface has a little SSH button when you do a deployment, it handles the keys for you automatically. So you don't have to keep track of your private key, and it just handles the keys automatically for you, which is kind of nice. But aside from that, it's pretty much the same as Azure and AWS. The optional installs, so you have the same exact optional installs across all 3 clouds, and the same list of components you can install, like Command Center, MadLib, so forth. And as we add new optional installs to this list, it'll be across all 3 clouds. And again, you can do this after the fact with the gpoptional command. And this is what it looks like from the UI the different drop-down list of different optional installs. And it's the same experience across clouds. And that's really what we've strived to do, is to make it as easy and seamless as possible for customers to switch between clouds, because we want to make sure that you can run Greenplum anywhere, including the cloud marketplaces or on-prem, or with a dedicated hardware, something like our Greenplum building blocks. Our goal number 4 must be secure. So obviously, if you have critical data in your data platform, you want to make sure it's secure, whether you have PII, PHI, or other data. You want to make sure that it is secure, and you have confidence that it is that the deployment is secure and hackers can't get in. So the two main components of what we've done in our cloud marketplaces are templates and machine images, which are where that's where our scripts are installed and inside the machine images themselves. Those are all been reviewed and approved by the cloud vendors. And so that means that they reviewed, make sure that we are not doing something using a feature in an unintended way or using a deprecated feature. And the machine images are made sure they're scanned programmatically to make sure that those have all the security patches, are all up to date there. So we have the best practices implemented. So password authentication is disabled. So we're using those SSH keys instead. The Greenplum database is using MD5 encrypted password authentication by default. And then root login, for instance, is disabled. So there's data at rest encryption. In GCP, it's automatic. And then all of our deployments are deployed in a separate network to help make it easier for administrators in the cloud to segregate the Greenplum traffic from other traffic that you may have deployed in the cloud. So next, I'll be talking about some frequently asked questions. As you're watching this video, you may have said, what about different things? And I have come across some common questions, and I thought I'd talk about those. So encryption, documentation, feature comparison, and licensing are usually the topics people ask about. So encryption, Amazon has EBS encryption, and it's either flag on or off, so you can have that very easily. Azure, we found the best thing to do is use a partner, and Failsmoremetric, for instance, is a partner of ours that can encrypt data at rest. And GCP is automatic. All of their disks are automatically encrypted. Documentation. So we have two main documents for cloud deployments. And these are the release notes, which is detailed information about the cloud deployment, whether it be Amazon, GCP, or Azure. It has all the different resources listed out. It has it's very detailed information there. Those are located on each marketplace listing. So you'd have to go to this Amazon, GCP, Azure marketplace and click on the link to actually see this. There's an overview document. It's a one-page overview document that shows the features, the highlights of the different cloud marketplace listings and has all the features associated with it. These are located also on the marketplace listing itself. And this is what it looks like. So on GCP, there's a tutorials and documentation, has the overview and release notes. Azure has and AWS both have an extra link there for the reference guide, but they also have the overview and the release notes. But these are also specific to the cloud. So this is a GCP release notes, AWS release notes, and Azure release notes. And then the feature comparison, what's in one versus the other. So the marketplace, we have a BYOL license or hourly license. BYOL is bring your own license. This is the same license you have on premise. So you can use the same license on premise that you have, that you would use in the cloud. There's no switching cost. You can deploy on premise, move to the cloud, move back to on premise, however you want to do it. It's up to you, whatever makes sense for your business. There's also an hourly license where we get charged by the hour to use the product, and those are both available. Both those marketplace listings are available in all three clouds. The tools, a GP browser, PG bouncer, optional installer, and upgrade utility are all available in all three clouds. The self-healing, they're implemented slightly differently in the three clouds, but it's available in all three clouds. The backup restore with Snapshots is available in all three clouds. And disaster recovery is available in AWS and GCP. So Azure doesn't have that quite yet. So GCP, when you create a snapshot, those are global resources. And so they're automatically available in all regions. And so you can do a restore for a disaster recovery. AWS, you have to copy the snapshot. The GP Snap has an extra feature in AWS where you say GP Snap, copy the name of the snapshot and then where you want it to go. So you can use that for disaster recovery. Licensing. So we have three different choices here. There's a Pivotal Web Services option. So if you're not familiar with Pivotal Web Services, it's a marketplace feature we have for Pivotal, where you can have basically go to the website and there are tiles you can pick for different services, and one of them is Pivotal Greenplum. And this is a fully managed, automated maintenance, multi-tenancy database. So you get your own schema to deploy Greenplum. And so that way you can tie into your existing applications or test and check out Greenplum with no cost whatsoever, and start learning how to use it right away. So there's also bring your own license, which I mentioned a minute ago, but there's the licensing we have is based on cores. So Amazon and GCP uses hyperthreading. So when you look at the number of vCPUs, virtual CPUs there, 2 vCPUs equals 1 core because of hyperthreading. In Azure, the instance types we have do not have hyperthreading. So for those deployments, counting vCPUs is a 1-to-1 to cores. So 1 core equals 1 vCPU. And it's the same support as on-premise. So you get the same level of support that you have with bring your own license, whether it be on-premise or in the cloud. And there's also a 90-day eval in the EULA, in the end user license agreement. This is without support though. So, but what this means is you can do an evaluation using the BYOL listing for 90 days for free. You have to pay for the infrastructure cost, of course, but from the licensing perspective of Pivotal, you're not paying anything. And there's lastly a metered pricing, which is you're paying 50 cents per core per hour to use that. And that does come with support. So thank you, and I hope you enjoyed this recap of the Greenplum Summit presentation for Greenplum running the cloud and scale matters.